Have you ever seen a dry thunderstorm? I used to see them all the time when I lived in Nebraska. It's so humid here in Tennessee, though, that they are fairly rare indeed. They have been common in Texas, Oklahoma, and Louisiana this past summer, contributing to a record-breaking wildfire season. Mesoscale weather is the mid-sized events that affect an area from a few miles to 200 to 300 miles across. Until the 70s, weather forecasting was mostly synoptic scale, which might cover a region the size of the lower 48. This was mostly due to the lack of data at a fine resolution. This scale affects the mesoscale weather. Mesoscale is now possible because of mesonets, ASOS, radar, satellites, etc. that have greatly improved the spatial resolution of weather data. Fire weather has been in the news a lot this summer because of all the problems with fire, especially in Texas. Smoky air can rise as high as 40,000 feet well into the stratosphere. When smoke and hot air rise, surrounding air flows in to replace the rising air, feeding more oxygen into the fire. This also causes high wind speeds, which can be devastating and dangerous. Smoke rising includes water vapor already in the air, but also water vapor the fire has added from the vegetation. As this air and smoke rise, water vapor condenses with the help of smoke particles, which serve as the condensation nuclei, and this becomes a pyrocumulus cloud and sometimes even a thunderstorm. Some particles might also provide a charge for lightning, which can even worsen the situation. Sometimes a light rain or drizzle might fall as a result. Fear of deadly microbursts may occur if the storm collapses, and it also may produce winds as great as 75 miles per hour. Santa Ana winds are a good example of mountains' effects on winds. They blow from the high deserts east of inland Southern California and through the passes and canyons of the San Gabriel and San Bernardino Mountains, down to the LA Basin and San Diego County. As winds blow down the mountains, the air warms at the dry adiabatic lapse rate of 5.5 degrees per 1,000 feet. During the winds these drying winds increase evapotranspiration, drying even more the dry chaparral brush. This can be a great fire hazard. I experienced similar winds called Chinook in Nebraska. They would bring the most amazing temperature changes. These winds are also called adiabatic or fawn, which means fire winds. Katabatic winds are the cold, dense air that flows downhill, also known as gravity or drainage winds. Such winds on Antarctica can shove pieces of ice away from the coast, even in the winter. Exposed ocean immediately freezes, expelling some of its salt and making the underlying ocean even saltier and denser. The cold, dense water sinks towards the bottom, 2.5 miles down, to become the Antarctic bottom water, which then spreads across the bottoms of the world's oceans. This is part of the meridional overturning circulation we already learned about. My, everything sure is connected, isn't it? Thunderstorms may come together to form squall lines or clusters called mesoscale convective systems, which may occur almost anywhere on the planet except in extremely cold areas. They are responsible from 30 to 70% of warm weather rain in the central U.S. They also produce microbursts, hail, tornadoes, lightning, and floods. A squall line is a line of thunderstorms moving across the countryside. It may be as narrow as 50 or as wide as 500 miles. They are commonly found along advancing cold fronts, and they usually form in late morning and fade sometime after dark. A derecho is an extremely dangerous squall line that forms downbursts along a long path of hundreds of miles. In the U.S., these form mostly east of the Rockies from May to August. A bow echo, about 10 to 60 miles long, forms when the rear inflow jet flowing into part of a squall line grows stronger than usual. It creates a system of thunderstorm cells that can produce damaging winds. Almost all derechos produce bow echoes, the most destructive aspect of derechos. However, not all bow echoes are part of a derecho. The MCC usually begins forming from a disorganized cluster of thunderstorms in the late afternoon. It normally falls apart around dawn. Vortex can actually last for several days. A full-blown MCC is a mix of layers of stable and unstable air and boundaries between cold and warm fronts. Some parts of the MCC have an on and off again rain that's typical of the thunderstorms along or ahead of a cold front. Other parts have the lighter but steadier rain typical of an area ahead of an advancing warm front. In order to have night thunderstorms likely with heavy rain, an MCC needs a rich supply of moisture, which southerly low-level jet streams can supply. Winds in these jets can exceed 60 miles per hour within a couple thousand feet above the ground, whereas on the ground it might be relatively calm. This hauls in humid air from over the southern plains and the Gulf of Mexico into the Great Plains region. Winter warm fronts can cause the dreaded winter mix of snow, sleet, and freezing rain. An ice storm lasting several hours and depositing more than a quarter of an inch of ice is considered an official ice storm by the National Weather Service. Most of the West has a wet season during the cool season and a dry season during the warm months.